Let's talk about the glasses.
Sure.
This was wild.
Yeah.
I put on a pair of Ray-Bans. I like the way they look. They're clear. They look like any other Ray-Ban glasses, except that I could call out to the glasses. I could just say, hey, Meta, I want to listen to the Bach variations, the Goldberg variations of Bach. And Meta responded, and no one around me could hear, but I could hear with exquisite clarity. And by the way, I'm not getting paid to say any of this. I'm just still blown away by this, folks. I want a pair of these very badly. I could hear, okay, I'm selecting those now, or that music now, and then I could hear it in the background, but then I could still have a conversation. So this was neither headphones in nor headphones out. And I could say, wait, pause the music, and it would pause. And the best part was I didn't have to, quote unquote, leave the room mentally. I didn't even have to take out a phone. It was all interfaced through this very local environment in and around the head. And as a neuroscientist, I'm fascinated by this because, of course, all of our perceptions, auditory, visual, et cetera, all occurring inside the casing of this thing we call a skull. But maybe you could comment on the origin of that design for you, what the ideas behind that and where you think it could go, because I'm sure I'm just scratching the surface.
The real product that we want to eventually get to is this kind of full augmented reality product in a kind of stylish and comfortable normal glasses form factor.
Not dorky VR headset, so to speak.
No, I mean,
because the VR headset does feel kind of like
it will,
like
but
thing on the face.
There's going to be a place for that too, just like you have your laptop and you have your workstation, or maybe the better analogy is you have your phone and you have your workstation. These AR glasses are going to be like your phone in that you have something on your face and you will, I think, be able to, if you want, wear it for a lot of the day and interact with it very frequently. I don't think that people are going to be walking around the world wearing VR headsets.
Let's hope.
But yeah, that's certainly not the future that I'm kind of hoping we get to. But I do think that there is a place where for having, because it's a bigger form factor, it has more compute power. So just like your workstation or your kind of bigger computer can do more than your phone can do, there's a place for that. When you want to settle into an intense task, right? If you have a doctor who's doing a surgery, I would want them doing it through the headset, not through their phone equivalent or the just kind of lower powered glasses. But just like phones are powerful enough to do a lot of things, I think the glasses will eventually get there too. Now that said, there's a bunch of really hard technology problems to address in order to be able to get to this point where you can put kind of full holograms in the world. You're basically miniaturizing a supercomputer and putting it into a pair of glasses so that the pair of glasses still looks stylish and normal. And that's a really hard technology problem. Making things small is really hard. A holographic display is, it's different from what our industry has optimized for 30 or 40 years now, building screens. There's a whole kind of industrial process around that goes into phones and TVs and computers and increasingly so many things that have different screens. There's a whole pipeline that's gotten very good at making that kind of screen. And the holographic displays are just a completely different thing, right? Because it's not a screen, right? It's a thing that you can shoot light into through a laser or some other kind of projector, and it can place that as an object in the world. So that's going to need to be this whole other industrial process that gets built up to doing that in an efficient way. So all that said, we're basically taking two different approaches towards building this at once. One is we are trying to keep in mind what is the long-term thing that it's not super far off. I think within a few years, I think we'll have something that's sort of a first version of kind of this full vision that I'm talking about. I mean, we have something that's working internally that we use as that we'll use as a dev kit. But that one, that's kind of a big challenge. It's going to be more expensive, and it's harder to get all the pieces working. The other approach has been, all right, let's start with what we know we can put into a pair of stylish sunglasses today, and just make them as smart as we can. So, for the first version, we worked with, we did this collaboration with Ray-Ban, right? Because that's well accepted. These are well-designed glasses. They're classic. People have used them for decades. For the first version, we got a sensor on the front so you could capture moments without having to take your phone out of your pocket. So you got photos and videos. You had the speaker and the microphone so you can listen to music. You could communicate with it. But it was, that was sort of the first version of it. We had a lot of the basics there, but we saw how people used it and we tuned it. We made the camera is like twice as good for this new version that we made. The audio is a lot crisper for the use cases that we saw that people actually used, which is some of it is listening to music, but a lot of it is like people want to take calls on their glasses. They want to listen to podcasts, right? But the biggest thing that I think is interesting is the ability to get AI running on it, which it doesn't just run on the glasses. It also it kind of proxies through your phone. But I mean, with all the advances in LLMs, we talked about this a bit in the first part of the conversation, having the ability to have your Meta AI assistant that you can just talk to and basically ask any question throughout the day is, I think it'd be really fascinating. And, like you were saying about kind of how we process the world as people, eventually I think you're going to want your AI assistant to be able to see what you see and hear what you hear. Maybe not all the time, but you're going to want to be able to tell it to go into a mode where it can see what you see and hear what you hear. And what's the kind of device design that best kind of positions an AI assistant to be able to see what you see and hear what you hear so it can best help you? Well, that's glasses, right? Where basically has a sensor to be able to see what you see and a microphone that is close to your ears that can hear what you hear. The other design goal is, like you said, to keep you present in the world, right? So I think one of the issues with phones is they kind of pull you away from what's physically happening around you. And I don't think that the next generation of computing will do that.
I'm chuckling to myself because I have a friend, he's a very well-known photographer, and he was laughing about how, people go to a concert and everyone's filming the concert on their phone so that they can be the person that posts the thing, but like there are literally millions of other people who posted the exact same thing, but somehow our unique it feels important to post our unique experience. With glasses, that would essentially smooth that gap completely.
Yeah, totally.
You could just worry about it later, download it.
Yeah,
there are issues I realize with glasses because they are so seamless with everyday experience, even though you and I aren't wearing them now. It's very common for people to wear glasses. Issues of recording and consent.
Yeah,
right?
that's
like if I go into
the
a locker room at my gym.
That's where we have the
I'm
light
assuming
on
that the people with glasses aren't filming. Whereas right now, because there's a sharp transition when there's a phone in the room and someone's pointing it, people generally say no phones in locker rooms and recording.
Yeah.
So that's just one instance. I mean, there are other instances.
But we have the whole privacy light. I don't know. Did you get a chance
didn't get a
to see
chance
this?
to explore that.
Yeah. So it's anytime that it's active, that the camera sensor is active, it's basically like pulsing a white bright light.
Got it.
So, which is, by the way, more than cameras do.
Right.
Phones,
Someone
right?
could be
It's
holding a phone on the sly. Right.
Phones aren't kind of showing a bright sensor when you're taking a photo. So,
no, people oftentimes will pretend they're texting and they're actually recording. I actually saw an instance of this in a barbershop once where someone was recording and they were pretending that they were texting, and there was
interesting.
There was a pretty intense interaction that ensued, and it was like, wow, it's pretty easy for people to feign texting while actually recording.
Yeah, so I think when you're evaluating a risk with a new technology, the bar shouldn't be, is it possible to do anything bad? It's, does this new technology make it easier to do something bad than what people already had? And I think because you have this privacy light that is just broadcasting to everyone around you, hey, this thing is recording now, I think that makes it actually less discreet to do it through the glasses than what you could do with a phone already, which I think is basically the bar that we wanted to get over from a design perspective.
Thank you for pointing out that it has the privacy light. I didn't get long enough in the experience to explore all the features. But again, I can think of a lot of uses. Being able to look at a restaurant from the outside and see the menu.
Oh, yeah.
Get status on how crowded it is. As much as I love, I don't want to call out, let's just say app-based map functions that allow you to navigate and the audio is okay. It's nice to have a conversation with somebody on the phone or in the vehicle, and just it'd be great if the road was traced where I should turn.
Yeah, absolutely.
These kinds of things seem like it's going to be straightforward for meta engineers to create.
Some future version will have it so it'll also have the holographic display where it can show you the directions. But I think that there will basically just be different price points that pack different amounts of technology. The holographic display part, I think, is going to be more expensive than doing one that just has the AI, but is primarily communicating with you through audio. So I mean, the current Ray-Ban Meta glasses are $299. I think when we have one that has a display in it, it'll probably be some amount more than that, but it'll also be more powerful. So I think that people will choose what they want to use based on what the capabilities are that they want and what they can afford. But a lot of our goal in building things is, we try to make things that can be accessible to everyone. Our game as a company isn't to build things and then charge a premium price for it. We try to build things that then everyone can use, and then become more useful because a very large number of people are using them. So it's just a very different approach. We're not like Apple or some of these companies that just try to make something and then sell it for as much as they can. Which, I mean, they're a great company. So I mean, I think that model kind of is fine too. But our approach is going to be we want stuff that can be affordable, so that way everyone in the world can use it.
Along the lines of health, I think the glasses will also potentially solve a major problem in a real way, which is the following. For both children and adults, it's very clear that viewing objects, in particular screens, up close for too many hours per day leads to myopia. Literally a change in the length of the eyeball and nearsightedness.
Yep.
And on the positive side, we know, based on some really large clinical trials, that kids who spend and adults who spend 2 hours a day or more out of doors don't experience that and maybe even reverse their myopia. And it has something to do with exposure to sunlight, but it has a lot to do with long viewing things at a distance greater than 3 or 4 feet away. And with the glasses, I realized one could actually do digital work out of doors. It could measure and tell you how much time you've spent looking at things up close versus far away. I mean, this is just another example that leaps to mind. But in accessing the visual system, you're effectively accessing the whole brain because it's the only 2 bits of brain that are outside the cranial vault. So it just seems like putting technology right at the level of the eyes, seeing what the eyes see, is just got to be the best way to go.